Hello, I wanted to walk through a little visualization of the 5-tuple PDA that we learned in class. And I just wanted to do this in preparation for the retake tomorrow in case it helps anyone. I kind of struggled with the PDA for a while, and so this has really helped me. Whenever you get this question asked, you can just write out this formal definition for whatever the PDA is. And so it's again just the machine that we're building that will accept the strings that we want it to and not accept the strings we don't want it to. And so an example here, AABB, so this is properly nested parentheses from our textbook. The A's and the B's correspond with open and closed parentheses respectively. And so a string like AABB would be something that our machine would want to accept. And so you can see right here, we have A and B, and we'd also have it union with our square symbol. We have our money symbol and S. We have the Q as our state, and our start state is also Q, and then we'll have 6 transitions here. And so writing out whatever this is for the PDA that you're given is how you would solve this question. And so we also have this tape and we have this stack. And one thing that I kind of struggled with when we started on the PDAs is what the actual symbols were doing. And so with this money symbol, it's always going to be at the base of the stack, and we'll have this square symbol that should be at the end of the tape. And so whenever we click through different strings, you can see that's what's actually getting put on the tape that we read through. And so if we look at an actual example, say we look at the example AAABBB, and we load that on. So we're starting out, the first letter we're going to see is A, and the first thing on the stack we're going to see is the money symbol. And so when we solve this problem, along with filling this out, when we fill out all of the transitions, we're filling out every possibility of combinations that we can see. And so let's start with this example. We're in state Q. And the first thing we read on the tape is A. So this is, first symbol is what state we're currently on. So we're on state Q, and for this problem, we never leave state Q. The second symbol is what we actually see, whatever next letter of the string is, A, and then what we see on the stack. And so whenever we look at the stack, we're actually popping whatever it is off the stack. So the stack would become empty when we see this. And so given that this is an open parenthesis, so this is going to be a string that we would accept so far, and we just saw this money symbol, we're actually going to want to replace the money symbol and put it back on. And so we transition, this is where we're going to go. We stay on state Q, we move right along this tape, and then we replace the money symbol to put it back on the bottom, and we put an S to symbolize that the tape has just hit an A. And so again, with this being properly nested parentheses, if we had AAABBB, that would be 3 open, 3 closed parentheses. And so just to give a quick visualization of what that would do to the stack, given that an S, we put an S on the stack to represent that we just placed something on the stack, what it would look like, given that there's 3 A's, 3 B's, is simply, if you look right here, S, 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 and then we get to the B's, take one away, take one away, take one away. So simply 1, 2, 3, 1, 2, 3. And so with these two symbols, we have the square and we have this money symbol. I like to think of these like this is the ideal couple. As soon as we are at the end of the tape and we're going to read this square in, if we see that this money symbol is at the bottom of the stack, we are good to go. So you can see when I hit step here, boom, we've accepted this string. We've hit that square, we've hit that money symbol, we're done. And so if we look at an example AABB, we're going to look at each of these transitions. So we started out, we saw A, we saw the money symbol. Then we put the money symbol back on the bottom of the stack, and we put an S to symbolize that we just hit one of our A's. But now what's different is that when we go through the next transition, we're actually going to see an S instead of the money symbol. And so here, we saw an A, we saw an S instead of the money symbol, and so we actually put that S back because we're still adding up, and then we put another S on top of it. And so when we get to B, we see a B, we saw the S, and we stay in state Q because that's all we have. We moved right because we're just moving forward, and then we hit this epsilon because basically when we saw that S, we popped it off, but we're just not going to put another S on, so we're just moving past it. And then we're doing the exact same thing again. We saw that S, we popped it off, and now we're at our favorite couple here. Done. We were in state Q, we saw the square, we saw the money symbol, and then we're not going to move, and then we just epsilon out of it, we're done. And if we were to do something like BA, where we start with the wrong symbol, we know immediately that's not going to work. So as soon as we step, we were in state Q, we saw a B, but we saw the money symbol, meaning that there was nothing on the stack. So something clearly went wrong. So you can put like a money symbol here to just stay in a loop forever. And so that's basically how this works. Epsilon, square, money symbol, good to go. If we had something like strings of the form 0n, 1n, the way I like to start this out, I always like to write what we know. And so I know that we have 0 or more zeros followed by 0 or more ones, and they have to be equal to each other. And so the extra requirement here is that all zeros have to go before all ones. So if we saw with the properly nested parentheses, we could actually go AAA, BBB, and then go, you can see the stack goes 1, 2, 3, 1, 2, 3. But then we also could do something like AB, AB, and go up, down, up, down, up, down, complete. Because those are also properly nested parentheses. And with something like strings of the form 0n, 1n, we actually cannot ever go back to the zeros. If we were to do something like that, it would automatically get rejected. We don't want that to be the case when we're building this machine out. And so other than that, it plays in a very similar way. We have 0, 0, 0, 1, 1, 1. An easy way we can make the circumstance so that we don't allow it to go back is we just add a new state. And so we start out in Q0, we read a 0, we read the money symbol, and then we replace the money symbol, we put an S, and we move forward. But as we continue along this string, we eventually get to a situation like this where we see a 1, so we're in Q0, we see a 1, we saw an S, and then we're moving to Q1, to the next state, so that we know that we don't allow for a situation where we go back to zeros. And so we step, step, and then we see this square and this cash symbol, and we're good to go. We got the square and the cash symbol, and then we finished. Now, when we're actually answering this question, we're building the machine. So you write out what each of these symbols are, and then you also have the square symbol here, so A, B, and then how we saw in class, union, and then the square symbol. And then you write out every single transition that could happen. So what state you're in, what you could see on the tape, you can see A, B, or square, and then what you could see on the stack. So here you can see the cash symbol or the letter S. What would you do then? If it's something that wouldn't work, like if you saw here, A, B, and then you see a square and the S symbol, then you can see an example. You can just put an S right back on and just stay in a loop, because that's not, we're supposed to have this square and this cash symbol, and then we're good. And so as you're writing through all of these transitions, and as you write out the formal definition here, that's how you actually build the machine that would accept the strings it's supposed to. These are all specific examples, but just like with the finite automata that we learned at the beginning of class, we're building a machine that would accept all possible strings for the requirements. An easy way that you know how many transitions you need is we have 0 and 1 here, and then we also have the square, so that's 0, 1, and square. That's 3 total items. The stack, we have the cash symbol and an S, and then we have two states, Q0 and Q1. And so multiplying 1, 2, 3 times 1, 2 times 1, 2, that's 3 times 2 times 2 is 12 total states. And that's just how you have to account for every possibility. Most of them aren't going to work. Like we can see there's just a lot of rejects. If we're in state Q1, we really want to see this square and this cash symbol together. And yeah, if this helps, let me know. Thank you all so much.